Welcome back to Garage Time. Today I need to do a little bit of fabrication on the brake pedal. This is a mock-up brake pedal. I didn't have the right thickness metal. Now I do, so I'm going to be doing the brake pedal today and hopefully have time to do some electrical assembly inside the car. Stay tuned.
Garage Time.
This is the original brake pedal, or what's left of it. I tried pretty hard to make this work, but it won't. Here is the new metal. It's the same thickness. This is 5/16, and it'll work, but I started thinking about some alternate designs. In fact, my friend Ian suggested maybe you should make a tubular pedal so that it doesn't have as much flex when you push on an angle. You know, sometimes your foot is not pushing directly on the pedal. It might flex it to one side. And then I thought, well, I'm going to put my engineering hat on and completely overkill this. So I'm going to take you into my office and show you some computer work that I've done to estimate the deflection of both brake pedal designs and just mess around for overkill's sake. Okay, here we are in my computer. There are two designs. This one is the one I currently have. It's made out of essentially sheet metal, even though it's 5/16 inch. This is where it pivots in the pedal box. This is where the brake balance bar goes. And this design is kind of an alternate using tubes as opposed to bending the flat sheet into the same shape. So if I push these together, I can superimpose them onto each other and they're essentially exactly the same. These tubes here line up roughly in the same place, and then the brake pedal positions are about the same. They're at the top. So these are equivalent designs, just different materials and probably different strengths. So let's analyze that. Okay, to get started, I applied a force here on the end of the brake pedal. It is directly in line with the pedal. It's 80 pounds. That's more than enough force in my brake system to lock up the tires. And then down here, this is where it attaches to the pedal box with some bearings. The computer can analyze the stress of the part and it will show the deformation. So I'm going to turn that off for a second. Now you can see where the force is applied, and here are the stresses. So the yield strength of this material is well beyond this scale. This goes to 1.5 times 10 to the 8th. The yield strength is 6.2 times 10 to the 8th. It's way up here. So we're not even close to permanently bending this brake pedal, but just for purposes of illustration, you can kind of see where the stresses are. Here's where it starts to neck down a little bit, and there's the bends in there, so it is some twisting action on the brake pedal. So there's stresses there. There are some stresses here in the tube where it attaches. Here are the bearings, no stress. And then between the tube, it starts to flex a little bit. You can see some stress, mostly as it gets closer to the pivot area. So this software will also allow me to show the deformation, what it looks like as it's actually bending. Let's slow this down a little bit. So this is me pumping the brake, so to speak. And you can see how stresses are developing. The next thing I did is I took the same pedal and the same force, but I'm putting the force now on at an angle. This is a 20-degree angle. From here, this is how I put it on before, and now it's coming in 20 degrees. So this is a little bit more realistic since you're using your right leg, and if you're not pushing straight on the pedal for some reason, this is pretty extreme, 20 degrees. That's going to cause this to deflect more this way, and let's see what happens. So let's turn the stress on this one. You can see the colors haven't really changed that much. The scale is roughly the same, and there's still no chance of bending the pedal permanently. But what's interesting when you turn the animation on is you can really watch how the pedal is, let's slow this down. Again, this is exaggerated and it looks like it's bending a lot more in this direction than it does in this direction. And that kind of makes sense. If you look at the shape of the pedal, it is going to be very strong in this direction because it has so much thickness to it. But in this direction, it's really thin. So it tends to bend this way. And we can also look at the displacements. So this particular design with 80 pounds, this is showing a plot of displacement in millimeters. So at the very tip, it's displacing a maximum of 2.3 millimeters. That's both in this direction, but most of the displacement is in this direction. So going back to the previous design, the displacements when you push the force directly on was only 1 millimeter. Now I talked about adding some gussets here at the bottom, which may not do much good. There's not much stress down here. Or adding some webs on the back of this to strengthen it from pivoting in this direction. But that's the benefit of a tubular design, is it's the same strength in both this direction and in this direction. So let's look at that one. Okay, for this design, I just went right to the angled 20-degree force, still 80 pounds. This is what the stress looks like. Now this one has more stress, so the yield strength here is still way off the chart, 6.2, but now the top of the chart is about half of that. So this one does have more stress in it. There is a spot down here right where it gets welded in the fish mouth, pretty high stress. That would probably be something to gusset from this balance bar tube down to here. This material is 1 inch by 0.93 wall, which is pretty thin, pretty lightweight. If you look at the displacements for the same amount of force, this thing is 1.7 millimeters. 1.7 is less than the deflection due to the thin bar that we showed before. So this one does have some advantages, although it is higher stress. So then, while I'm here overkilling, I thought, why not just put the web on the backside like I was going to do anyways and see what those results are. So for this, the load is the same. The stress now is still very low. 6 would be way up here. This is at 2.9. The plate does take some of the stress. You can see it start to develop a little bit of color, and it should help in terms of the deflection. So if we shift over to the displacement, this has a total displacement of 1.3. So I can animate the displacement. So in this case, the red is not the stress. The red is how far it displaces. So obviously it's going to displace the most at the end. And it is still shifting to the left. The whole pedal is bending to the left, which is to be expected. The plate helps it a little bit. It actually brings it down to 1.3. That's less than it was with the tubular design. So the next thing I did is I tried to break it. I'm putting 250 pounds on now on the same angle. So let's look at these results. So now the yield stress is on the chart. So this arrow is what the yield stress, this is just regular steel. It's at 6.2 times 10 to the 8th, and we're starting to see the stress creep up towards the yield strength. So nowhere near this sort of green-yellow, but we still have a little bit of blue-yellow here, so we're starting to creep up on that. Now 250 pounds with a single foot, you know, that is really a panic situation, maybe even an accident situation. I don't see the pedal continuing to yield right here. The displacement is now at 4 millimeters, and I will animate this deformation. Even though the force was tripled, the computer is going to exaggerate it to almost look the same. But what's really matters here is the total amount. This was moving, when it gets to the red, it's moving 4 millimeters. Now in reality, with this much force, the pedal box is going to be bending too, and so is the floor it attaches to. This is only analyzing the brake pedal. So the other thing about this pedal design is it does allow me to use the stock recoil spring because it latches around the back of the pedal. That's a plus on this design. So there you go, a little diversion into engineering and some of the tools that we use to evaluate which design's better. You know, there's more to it than that. That software is not perfect. It does make mistakes. Now I'm going to try to cut this out. This is hard to cut out and bend. So if I can't bend this like the factory one was bent, then guess what? I'm doing the tubular design. You got to be able to make it too, not just design it. Not the smoothest cut, but I needed to get through it somehow. Okay, I'm pulling on the press really hard right now and I'm starting to get nervous. It is bending, but I'm starting to see some things moving in the dies that I don't like. So I'm gonna stop here and reevaluate if there's a way to make this easier. Here's the change I made in the tooling. So this is the bottom die and the spacing here is about 1 inch. Spacing here is probably 2.5 inches. So when the upper die comes down, it spreads the load over a wider area. And so it's easier to bend when the forces are spread apart. That's why I did this. It reduced the tonnage significantly. Definitely be safe, guys, when you're using your press. Okay, this piece, I got both bends in it and I'm just checking to see that they're parallel. Here the bubble is pretty level. And then if I move it, it looks like I might have overbent it, you know, just a tiny bit, but it's good enough for a brake pedal. I didn't cut this entire thing out. I didn't put the holes in here and this half moon shape in there because I was not sure I was going to be able to bend that. It did work out, you know, when there's a will, there's a way. But I got to a point where I was stuck and I felt like it was dangerous. So if you get to that point, you got to stop, reevaluate. I changed the tooling, which wasn't that big of a deal. And now I have something that's bent pretty nicely and pretty close to what I had previously. Okay, I have a tremendous amount of grinding to do on this thing. Because it's so thick, the cuts are not that great. And I'm being conservative. I only have one of these bars, and so if I make a mistake, it's all over. Well, here we are. We have a brake pedal. It's made out of sheer determination. This is not the easiest way to do it. The easiest way to do it is to take that file I have on my computer and email it to a laser cutter, water jet cutter, and I would come back with a perfect part. But you can do this kind of stuff at home. I roughed it out with the plasma cutter and just did a lot of grinding on it till everything fits. So now it's time to weld it together, and this is an expensive pedal. If I was doing this engineering, a finite element analysis and comparison between pedals, I would probably charge someone, about $2,000, and that would not include the prototype. So just a little FYI into the engineering world, that's what it costs. Yeah, this is pretty tough to weld because it's so different in thickness. So what's happening is it's really cooking this thinner tube. So I'm going to let it cool down before I continue. But so far the welding is going okay. You just have to really focus on where the heat's going. I left this flange on here long. If you compare it to the other one, this is how thin it needs to be in order to clear the pedal box. But on this part, I left it long, and that's just to make it easier on the welding because I'm going to trim it later on. That prevents me from just chewing away or eroding the edge there. Brake pedal's now back in the box, and I don't have the bushings here on the end. I'm not done welding yet, so I don't want to put those in. It heats them up too much and the oil starts pouring out of them. But I am looking at now where to put these gussets. So previously and on the computer, I had showed them here on the back. But at full pedal travel, which you'll probably never ever do, that's going to limit some travel because it's going to be an extra piece on the back. So now I'm thinking about just putting the plate from here to here, you know, right here kind of centered on the length of the arm. So maybe something like mid position, like right like there. And then I can put one on this side. I can also put one on this side. As long as it doesn't contact the rubber boot, should be fine. That's what I was talking about right here, just thinning this web down. All right, so this tube gets centered right in between the push rods for even distribution right out of the gate. Okay, I just finished cutting one of the gussets here. So I'm going to tack this in and then measure the other side. Everything's been reassembled, and I decided on only doing one overkill gusset right here. I was gonna put another one on the other side, but that would be, you know, almost 2 inches wide, and that's enough. I mean, this enough is enough. It's definitely overkill. I know the deflections aren't that big. So I'm now focusing on getting the pedal positions correct. Right now, this position is adjustable. You know, it's adjustable back here, it's adjustable right here. And the position of the brake is adjustable in this direction by changing the lengths of the push rods. Okay, so just like that, I have The brake pedal is completely done. It's bolted together. You can see here the 2 bolts, and it has a little bit of adjustability now from left to right. So right now it's mounted on this side of the brake pedal. If I switched it to this side, it would move it away from the gas pedal. Right now it's a little closer than stock. So that's adjustable. I could also in the future, I suppose, drill some new holes and go up and down if I needed to. And then the in and out adjustment is done here on these push rods. These push rods would change the in and out measurement. And that's about all I can do on the brake pedal assembly. It needs to be taken apart and painted. So I'm not in the mood to paint right now. I'm just gonna collect a few other parts that need to be painted and put them in a pile, do it all at once. Okay, now I'm just trying to solder a loop on the end so I can pull the wires through. It's kind of hot. This tape is called friction tape, and it's not super sticky, so it's not going to just contaminate the wires. So I like to use this first, protect the wires a little bit. And this is the Gorilla tape. Just go one or two loops around on that. And then there's definitely some branches to the wiring harness. So I'm going to pull on this main section too with another loop. So I'll use 2 pull wires. Just fishing a second string in there. Okay, right here where my hand is, next to this trailing arm, there's a slight indentation in the seat pans. That's where the wire harness goes up over this torsion tube, and then it's going to come through here into this hole right there. So I'm going to start by getting the wires over the torsion tube first, because some of those connectors just won't fit. I won. You know, I did that myself, and I'm all sweaty. It was definitely a workout. Just pushing and pulling. You know, I had spliced that center section, and I had some PVC areas that were glued back together, and I think they were hanging up a little bit. So if it was a brand new harness, it might have been a little bit easier. But now that it's in, I just need to verify the position. I can slide it back and forth, but I need to look at the junctions in the footwell and look at some pictures and see exactly how to position it. There's also a little pigtail that lines up with the emergency brake. So that's in there. I just need to find it and find out how to position the harness correctly. Let me show you inside. Okay, there's one end of the harness right there with the blue string, and then this is the one with the green string. And they're coming out of that oval right there, and I don't think that's right. I think it's supposed to come out where either the tachometer cable is or the speedometer cable, or it comes out that big hole there near the pedal assembly. That's easy to reroute from here. It's just a small little step, but it's in, and all the big bundles are through. Okay, I'm gonna go inside and cool off and check out some pictures of how to position that wire harness, like I said. Hope you enjoyed the video today. I know that brake pedal is probably the most over-engineered brake pedal you're ever gonna see. See you next week.